All right, let's talk about the essential toolbox every single programmer needs. Today, we're prying it open to look at the absolute core tools you'll use to build pretty much anything, from a simple game to a massive app. Let's get right to it. You've been there, right? That feeling of déjà vu, where you're typing the exact same logic again and again and again. It's not just frustrating, it's super inefficient. But what if I told you there's a way to write that code just once and then reuse it whenever you want? Well, that's exactly what this is all about. Think of this as your first trip to the coding hardware store. We're going to grab the two most fundamental tools that solve this exact problem of repetition and help us build way cleaner and much smarter code. Okay, let's dive into our first section. The first two tools we're putting in our belt are called procedures and functions. Now, they sound pretty similar, I know, but they have one key difference that completely changes how you use them. And here it is, the big difference. A procedure is basically a list of instructions that just does a thing. You tell it, hey, run this task, and it does. That's it. A function, on the other hand, also does a task, but then it gives you something back. It gives you a result, a value, an answer. It's not just a command. It's more like a question that expects a response. So check this out. A perfect example of a procedure. We'll call it show_intro. Its only job in the entire world is to print a welcome message. It runs, you see the message, and its work is done. It doesn't report back, it doesn't give you any data, it just completes its one task. Now, in a lot of modern languages, you'd probably just call this a function too, one that just happens to return nothing, and that's totally fine. But now, look at a true function. See that magic word, return? That's the game changer. This function, calculate_score, doesn't just do something. It gives you an answer. It takes in a couple of numbers, kills and assists, does some math, and then that return statement literally hands the final score back to whatever part of the program asked for it. This is how you get a result, not just an action. So we have our basic tools. Pretty cool. But what if we want to make them more flexible? More powerful? That's where we level up. In this section, we're going to add some power-ups to our toolkit. Parameters and variables. So what are these power-ups? We call them parameters. Think of a function without parameters like a coffee machine that can only make one thing, blank coffee. That's it. By adding parameters like milk or sugar, you're giving it custom settings. Now that same machine can make you a latte or a cappuccino. You're making the same tool way more dynamic. Let's watch this happen. We can start with a really basic tool, a procedure that just says hi. Kind of boring. So step 2, let's give it an upgrade. We'll add 2 parameters, fan name and group. And just like that, our generic tool becomes this awesome customizable greeting machine. We can plug in Ariana and Twice and get a totally specific message. It's the same core idea, just made flexible with parameters. And here's why this is so huge for functions that return a value. To calculate a win rate, your function has to know 2 things, your total wins and your total games played. Those are your parameters. Without them, you'd literally have to write a separate function for a player with 10 wins and another for a player with 11 wins. That's insane. Parameters let one tool do the job for absolutely everyone. Okay, our next power-up is the variable, and this is a big one. The best way to think about variables is that they are the memory of your program. They're like little labeled boxes where you can store important info, a player's name, their high score, their current rank, so you can grab it and use it whenever you need to. But here's a really important detail. Not all memory works the same way. A global variable, like this player name equals Alucard, is out in the open. The entire program, every single part of it, knows who Alucard is. But a local variable, like rank equals Mythic Glory, gets created inside a function. It only exists in there. The rest of the program, it has no idea what that rank is. It's like a secret that's kept inside that one little piece of code. All right, we've got our tools, we've got our power-ups. Now let's put it all together and see how these simple little concepts come together to build something that we all actually use in the real world. We've all done it, right? You walk up to an ATM, you punch in your PIN, you get cash. It feels kind of like magic, but it's really just a series of these functions and variables, all working together perfectly. So let's pull back the curtain. How do these tools actually check your balance? So it all starts with a simple function. We can call it @mlogin. Its one and only job is to ask you for your PIN, and when you type it in, it stores that number in a little local variable called user PIN. Simple, focused, self-contained. And now this is where it all connects. The first function takes that user PIN variable and passes it as a parameter to a totally different function. Let's call it check balance. This second function takes the PIN you gave it, compares it to the correct one, and here's the key. It returns a value. If the pin is right, it returns your balance. If it's wrong, it might return 0 or an error message. And if that pin is correct, the check balance function returns this. That's the payoff. The final result delivered right to the screen. It's a perfect little chain reaction. A variable stored the pin, a parameter passed it along, and a function returned the final answer. Simple tools, but a really powerful result. So why do we even bother with all this? Because it completely changes how you code. Instead of one massive, confusing file, your code becomes easy to manage, with each tool doing one specific job. You stop repeating yourself. There's even a principle for this. Programmers call it dry. Don't repeat yourself. Write it once, use it everywhere. And maybe most importantly, it makes your code readable for other people, or even for you 6 months from now. This isn't just a suggestion. It's the blueprint for how good software is built. So there you have it. You've now got the fundamental building blocks of programming in your toolkit. Procedures to do things, functions to get answers, and parameters and variables to make them powerful and dynamic. They're the hammer, the screwdriver, and the wrench of the digital world. So the only real question left is, what are you going to build with them?